about the good evening about the review. Okay. So I propose you finish the last problem. We don't finish. Let's move on directly to the review. It doesn't matter if we have not finished everything, but in the review, I explained the theoretical part. The thing we don't see the lecture because we dedicate too much time and the rational function. And the review, okay, basically review is today plus next day, so November 5th, and not this, Thursday. And I suppose we finish the review. I send to you the test 3. The 3 is due next Tuesday. No? This is my plan. I don't know if I can accomplish this or no. No, si I don't accomplish it, well, entonces we extend a little bit more the test, pero I suppose que no. Okay. Let me know si you see the board or no. Let's see. No. Okay, no. Whiteboard here, over there. Okay. Okay. Share screen. Whiteboard.
Professor, I have a quick question.
Please go ahead.
There are 2 homeworks on Alex. You want both of those done to get credit for extra credit, correct?
Yeah. Remember the rule for the extra credit is 10 extra points if you complete the homework, pero both. And you get higher or greater than or equal 80%. Okay? So this is in both. Suppose in one you get, I don't know, 100. In the second, no. The second you get F or you get 70 or 75. No extra credit for you. So the rule is clear. Okay, let's move on to the whiteboard. Okay, wait a second. Do you see the whiteboard or no? No? Yes? 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 Yes. Okay. Look at the. Let me do fast. Good. Too fast. The last problem. The last problem I have here, look, is so we start this last class. X to the 4th power greater than or equal 4x to the 2nd power. This is inequality, no linear inequality, degree 4. Okay. Okay, remember the first step you should do is right hand side must be 0. Guy, this is mandatory. Another way I try to explain another tutor or teacher is wrong. Okay, because lost information. The right hand side must be 0 because in the last table, in the last chart, remember we compare positive, negative, and positive, negative is suppose 0 is the level of the C. Above, positive, and below, negative. The 0 is the level of the C. Because 0 is important to analyze the inequality. Okay, now I focus it in the left hand side. In the left hand side, I can see, is there common factor GCF? Yes, of course, is x squared minus 4 greater than or equal to 0. And you have the difference of a square. And the factorization is x squared, open two parentheses, xx to 2 plus or minus. Because I need to factor completely this expression. And the expression in the left, you factor completely. And this is my new inequality ready to analyze. Okay. Remember, temporary, you convert to equation. Because I want to find the critical value. The critical value is important, guys. Can help me to create the partition of the all real number line. Entonces, x squared equals 0. Es obvio que es only one solution, que es x0, x plus 2 equal to 0. Es obvio que es negative 2. And x minus 2 equals 0. Es obvio que es positive 2. And with this information, this is CB, critical value, and go immediately to the all real number line and create the partition. This is my famous all real number line. Okay, and the critical value is 0. Okay, nice. 2 and negative 2. So basically, we have 1, 2, 3, and 4 intervals. Y ahí select completely arbitrary testing point. I suppose que the nice testing point is negative 3, or negative 4, negative 5, negative 1 is good, positive 1 is good, and 3, 4, 5, 6, 7. So one guy inside each interval. Now created the chart, the table. Testing point. We have 3 factors. The first one is x squared, sorry. The second is, well, let me erase this, because in the column I put a testing point. Okay, x plus 2, x minus 2, and total sign. Okay, and the testing point are negative 3, negative 1, positive 1, and positive 3. And you evaluate this testing point into this expression. Okay. Look at that. Let's do only the first column. Negative 3 squared is positive. Positive, always positive. Why? Because regardless, see the value is negative or is positive, when you square becomes positive. So when this situation happens, remember in the analysis, the most important information is the negative sign. So how many negative signs? So the positive sign do not apport any information. Therefore, when you see one binomial or one factor que is a square, or not necessarily square, even exponent, you can delete. You can ignore this column because this column do not apport any information. I want to explain in detail more clear in one example of the review, because sometimes it's totally delete, like this example, and sometimes no, sometimes partial delete. But in your moment, I explain more clear. But okay, what is the thing you need to understand? Okay. Well, I come back to my expression, exponent 2, delete. Exponent no 2, stay. Exponent 1, again, stay. This basically stay this and this. Negative 3 here is minus, negative 3 is minus, and double minus is positive. Negative 1 here is plus, is minus, is minus. 1 is plus, 1 is minus, entonces es minus. And 3 is plus. Okay, so now I come back here. Remember our inequality is greater than? Yeah, of course. Our inequality is greater than means to be positive. And the true guy is this, and this, and this, and this. Okay, this and this. This is true. Negative, not true. In this example, not always happen. Thus I highlight the solution of the inequality. The testing point that passed the test was. Okay, let me a little bit make a zoom in. Okay, look. The testing point that passed the test is this guy. And negative 3 passed the test. This continues forever in that direction. This fell, and this passed. The new thing that brings me this example is, well, it's greater than or equal. Include the endpoint. So this endpoint is included bracket. But so basically it's the solution for the equation. But the solution for the equation contains 3 solutions, 0, negative 2, and positive 2. And negative 2 and positive 2, you indicate using the square bracket because square bracket indicate that negative 2 and positive 2 belong to the solution. However, 0 is totally isolated point here. Wow. I never seen before that. Okay, so what is the answer? What is the final answer? What is the solution set of this inequality? Solution set is in interval notation, right? From negative infinity, comma, negative 2, bracket, at this interval. Union, see, I try, the order is not important, because I try to follow the order from left to right. 0 is also solution, but 0 is just the point, no interval. Union, bracket 2, comma, infinity. End the story. This is the final answer. What is the reason I using curly bracket, square bracket, and parentheses? Square bracket indicate include the endpoint. And curly bracket is, when you solve the equation and you find the solution set for the equation, you indicate, suppose the equation, the one hypothetical equation, the solution is 1, 2, 3. So say your solution set, and one equation is 1, 2, 3, is 1, 2, 3. And you will using curly bracket. This is the typical symbolic way in algebra. Okay? Got it? Super. Okay, so you have no question. Let's move on to the review package. Question by question. The question gets graphic. We are using Desmos. I create for you one Desmos file. I send to you when they finish. Okay. Any question about this problem? It's okay. The two new things bring me this example. Number one, sometimes happen that one factor have exponent even. This is totally deleted. Some factor, when you have equal sign, include the endpoint and the interval, and sometimes, I don't know, depending the problem, we have isolated point, that also belong to the solution. Okay? Okay, guys. I have in the screen of the another computer, I have the review package. The question one say, question one. Review package. Review for test number 3. Question 1. Say 4x squared plus 13x minus 12 less than 0. It's an inequality. Polynomial inequality. What should I do? Well, right hand side is 0. Nice. I love you there. Right hand side actually is 0. Good. This is good. Now I factorization this trinomial. The factorization is a special trinomial 48. We multiply 4 times 12, 48, and the combination is 16 times 3, because 16 times 3 is 48, and 16 minus 3 is 13. Okay, guys, so you don't see the combination too fast like me, no problem. You in one corner of the piece of paper, you put 48, one by one. 48 times 1. 48 is 24 times 2. 48 is 16 times 3. And I suppose in one moment I got it, right? Okay, so it's 16 times 3. So you copy the first exactly the same. You break it down 13 and 16, positive and minus 3x, minus 12. Less than 0. Now group E. Factorization by group E. GCF in the first couple is 4x. X plus 4. GCF in the second couple is minus 3. Minus 3. Minus 3 out. X plus 4. And I can see that x plus 4 is common factor again. X plus 4. Open the last parenthesis, 4x minus 3. Less than 0. And this is my inequality. I need to focus my attention. Remember, after that, critical value. Critical value, you immediately convert this to equation. Temporary equal sign. And you isolate x plus 4 is 0. Then x is minus 4. And 4x minus 3 equal to 0. X is equal to 3 over 4. is in decimal 0.75. I put in decimal to see much better in the number line. And we're using this critical value. This is the CB, critical value, to make a partition. 0, infinity positive, infinity negative. Guys, I need to see this in the test. When you solve this kind of problem, one part of algebra and one part graphic. Okay, negative 4 is here. 1, 2, 3, and 4. Negative 4. 1, 2, 3. 0.75, I suppose like here. 3/4. This is my only two critical values. Yeah, I select totally arbitrary testing. Suppose -5.
Professor?
Please. Please.
Okay, you said you want us to draw the number line when we're doing the test to show to show the point?
Show the point. Exactly the same you see here. You are doing in your test. So some people that don't know anything, not you, of course, believe that the solution for this inequality is only algebraically. No. Well, there are ways to do that. So you are doing correct, but I don't teach that. So now, is one part is algebra, factorization, find the critical value, but using the critical value, you are doing the sketch. You are drawing the real number line, you are doing the partition using the critical value, and you select testing point, no? The testing point maybe 0 is good, no? In this interval, 1, 2, 3, 4, 5. I don't know. 1, 1, 1, 2. Let me select 2. Doesn't matter what you select. 0 is good and 2 is good. And 0 is good. And now, finally, you create the chart or the table, whatever you want to call it, in which you have one column that is TP, testing point. In our example, -5, 0, and 2. I select another 2, select another value, select 1, select 3, it's the same. Because this is one representative of this interval. Yeah, I suppose they have the same behavior. I suppose, no, I know they have the same. And you put the factors involved in the problem, que is x plus 4, and 4x minus 3, and one extra column, que is the total, in which you summarize overall sign. Okay. And relax, cool down, and plugging in one by one. -5 here and -1 and minus. I don't care the value, I care the sign only. -5 here is minus because -5 times 4 is -20. Minus 3, -23. And double minus becomes positive. If you want, I don't know why the total I enclose in the circle. This is my way. This is not exactly. You're doing your own way. You understand any smart way. 0 is positive and 0 is negative. Entonces negative. And 2 is positive because it's 6 and 2 is 8 minus 8 positive. Okay. Entonces now I come back to the original inequality. I can see less than. Wow, less than is negative. So the only true guy, the only testing point que pass the test is this. Therefore, I guarantee you that this interval is the solution of the inequality. Include the endpoint? No. Why not? Because we have no equal. Entonces, paréntesis and paréntesis. What's my final answer then? Final answer is -4, that weird point is 3/4. Paréntesis, paréntesis. 3/4. 3/4, remember this point is 3/4, 0.75, and this is -4. So from -4 and 3/4, positive, is the answer. Any question, guys? Super. Everyone understand very well this? This is easy, straightforward. Okay. Any question? No question?
Professor, the last part is 2 minus 3 should be minus?
Okay, and the last part is 4 times 2 minus 3. So I plug in these 2 here. You replace x here. This is 8 minus 3 is 5 positive. That is the reason I put 5 here. Super.
Thank you.
No problem.
Professor.
Can we take a picture?
Please. Come on. Go ahead.
Why is the negative sign true and the positive signs aren't true?
This is a good question. Okay. Remember, we investigate the sign of the polynomial here, but the solution for the hour inequality is control for this sign, less than. Basically, the thing we are doing is this polynomial, of course, with factorization, okay, but this polynomial, I need to investigate when it's less than 0. And less than 0 means to be negative. Therefore, the negative guy is the true. And the majority of the example we are doing in the lecture, no. Is that you put true in the positive because it's greater than. So greater than 0 or greater than or equal. It's the same. The true part is considered in the positive. However, the less than or equal, I don't care. The equal is not important. It's negative to true. Super, Jordan. Super.
Yes, sir. Got it.
Okay. Another smart question. Come on. No? Clear? Let's move on to the question 2. Okay. Question 2 now. Well, question 2 is easy, or relatively easy. It's graphic. This the rational function. Okay, so f of x equal x over x plus 3. And remember the methodology I explained, I don't remember, si it's 7 steps. No, number 1, number 2, number 3, number 4. Number 1 is factorization. Factorization of the polynomial at the top, factorization of the polynomial at the bottom. In this case, we cannot do anything because it's prime expression, so we have no hope. Conclusion, no hope. Because x and x plus 3, we cannot simplification, no? The rest is compute the y in a set and the x in a set. Equal to 0. You evaluate in 0, is 0 over 0 plus 3. It's obvious que es 0, that the point is that this is x value, and this is the y value. I suppose que this is a y in a set. The x in a set is the same in this example, no? Not always happen, but in this example, because it's x equal x plus 3, and you know, when it's 0, I ignore totally the bottom part and x equals 0. Therefore, confirmation, x0, y0. So 0,0 is both. It's y in a set and x in a set. Okay, super. Now, next step is compute the vertical asymptote. Vertical asymptote is when the polynomial in the bottom, que es x plus 3, is 0. Okay? Is x equal minus 3. Entonces, in this moment, I am doing one corner of the piece of paper, my sketch, my roughly sketch. After I want to do nice and decimals, of course. I plot the only point that we have, is 0,0. I know that my curve, this curve, passing through that point, and also in negative 3, 1, 2, 3, we have vertical asymptote. What about horizontal asymptote? We have or no? Yes or no? Remember, horizontal is the analysis of the degree. You compare degree at the top, degree on the bottom. It's the same degree, right? Degree is 1, 1. Degree of the top is 1, degree of the bottom is 1. So when you have the same degree, of course, yes, we have. Yes, we have. Yes, we have at x equals 0. X equal, sorry, carajo. Y equal 1. Where I come from this y equal 1. Y equal 1. Y equal 1. Que es the division, this number, invisible 1, and this invisible 1. Okay, so we are doing the graph of the horizontal asymptote. Okay, is y equal 1. The equation for this was x equal minus 3. And after that, well, I verification the symmetry. It's obvious that this function have no symmetry because when you replace x for negative x, we have minus x over minus x plus 3. So minus x over 3 minus x. This is never look like similar to this. No opposite sign, no the same sign. It's completely different. This is neither. So it's neither to say I need to plot the positive part totally independent for the negative part. And now selection the different additional point. How many additional? Well. Remember, the only information that we have in the x-axis is this point and this vertical axis. So I recommend using 1 point here, maybe 1, maybe 2, only 1, not necessarily too much. Remember, guys, x equal 1, and here in between 0 and -3, I select another -1 maybe, or -2, and after -3, maybe -4. And you have some idea how it look like the graph. Okay, now immediately, so you understand this, I switch into decimals and doing very well in decimals. Okay, decimals now. Switching screen, decimals. So I suppose, I don't know if you want to follow me in decimals, or you want to see my, okay, follow me, and also I will send to you these decimals, okay? When we finish, not today, Thursday, when we finish, I send to you this decimal. Okay, remember, I open the folder here. I want to call question 2, no? Question 2. Question 2. Question 1, no graphic. Question 2 is a graphic. Entonces, the point I have in my hand is 0,0. 0,0. Okay, blue color, 0,0. We have also the vertical asymptote is at x equal -3. Remember, vertical asymptote, I want always in black color. You click on the icon, hold the mouse, select the color, and select the style, dotted line. This is my vertical asymptote. And my horizontal is y equal 1. Y equal 1 again, pero dotted line because it's the asymptote. Asymptote is not the curve, it's auxiliary construction, auxiliary tools that guide me to do the actual graph of the function. Okay, the actual graph of the function is, let me call, you can call y, but I prefer f of x. For the reason I want to explain now. And you typing is x over division, parentheses, no, not necessarily parentheses, x plus 3. X plus 3, x plus 3, x plus 3. This is the graph. Look at that. Well, 0, 0 is a point. Then we need, suppose, additional point. Additional point here is maybe another line. Suppose que I evaluate I propose you in 1, no? 1, 2, then you type in here. Open parenthesis, 1, comma, F, evaluate 1, que es the Y value associated with that. We can compute it by hand, no? Pero not necessary. Look, the answer is 0.25. One more point I say, -1, it was good, no? Comma, separate by comma, if you want to use on the same color, no? -1, comma something, -1, comma F, evaluate -1. Boom. And one more point I say, -4, no? Okay, -4, entonces -4, comma, separate by comma. -4, comma, F, evaluate, using function notation, no? I take advantage the algebra que we are learning. -4, go. Open parenthesis, -4. Bang. You want more, you put more, -5, -6, negative, or +2, +4, but I have some idea. how my graph look like. Any question? Any question? Any question, please? Now is the moment. And the test, no, professor, I don't know. No. Call 911, no call 911. This is the moment to ask me. Any question? This is a review. And this, we reinforce and consolidation and summarize everything we learned so far. Of course, the review I am doing fast because I suppose you know that part. Okay. Let me try to go to the question number 3. Okay, question number 3 again. Let me go back to the whiteboard. There's a whiteboard. Okay, let me erase the whiteboard. Erase canvas. Okay, there you go. Number 3 is G of X is equal X squared, wow, minus 5X plus A. Ooh, so you immediately, I can see the board. Oh, sorry, coño. Santiago, okay, sorry. Switch it, screen share, board. Now you see or no? You see now, Santiago? Yes, no. Why no, Santiago? Everyone saw or no? All of Santiago? The rest? Yes, Rosalinda said yes.
Yes.
I don't understand, Santiago, what's going on with you? Okay, thank you, guys. Santiago, try to fix it. Okay, Sergio. Okay, what kind of function it is? It's a quadratic function, no? It's no rational function. Rational function is division, two polynomials. This is only quadratic function. A quadratic function, remember, we have two different ways. We have the vertex form and the general form, or standard form, sorry. Que es like ax squared plus bx plus c. Actually, I can see que a1, b is negative 5, and c is positive 8. Okay. So in this case, no factorization, and the only thing you should do is find the vertex. It's the most important point in this function. And the formula, remember, vertex is h comma k. The formula for finding h is minus b over 2a. You need to know by memory this. It's minus b is minus 5 divided by 2. A is 1. The double minus is positive is 5 over 2. And decimal, 2.5. Okay, this is h, 2.5. I need k. Then in order to find the k value, you evaluate. In order to find the k value, you evaluate g in 2.5. And you put in the calculator, no? Let me try to use my calculator. Now you plug in x equal 2.5 or 5 over 2, whatever you want to express it in fraction or in decimal. I put in my calculator. Let me try. The expression is x squared minus 5x plus 8. And the value I want to select to plug in is 2.5 positive. Okay, x equal 2.5. And the answer is, the answer is 7 over 4. The answer is 7 over 4 in fraction, but in decimal is 1.75. 1.75.
So you put in 2.5 for the whole x.
Here, you put 2.5 squared minus 5 times 2.5 plus 8. Okay? You are doing your own way in your calculator. I'm doing my own way in the calculator. The answer is 1.75. Therefore, the vertex is located at the point 2.5, 1.75. Okay? And this parabola open, upward. Open, up, because A is positive. When A is positive, look, it's positive 1. This parabola open up. So this parabola open up, and the vertex is located in this point. Okay? One more information we need. When we need axis of symmetry, is the line x equal 2.5, and we need extra point. O sea, bueno, no, sorry, coño. The classical point, que es y in a set, x in a set, o sea, you evaluate g in 0, is the y in a set, but it's obvious in this case 8. Remember, take advantage que C is the y in a set, that the point is 0.8. So at least we have another point. We have 2 points. The vertex is the most important, and one extra is the, and the x in a set, well, the x in a set you solve in the quadratic equation like that. E in x equals 0. Actually, we need to solve x squared minus 5x plus a equal to 0. Okay. Let's do it. This is nothing for us. It's the quadratic formula, minus b plus or minus square root b squared minus 4ac divided by 2. Entonces, minus 5, minus, double minus become positive. Plus or minus square root negative 5 squared, que es 25. Minus 4 multiplication by 1, multiplication by c, que es 8. Divided by 2 times 1. This is 25, but this is 32. Ooh. And 25 minus 32 is a negative number, right? A negative number inside the radical means imaginary. And when you in algebra try to find something, and the answer is imaginary or complex, what means that? What?
It means it doesn't exist.
Exactly. Mean that it doesn't exist. Okay? The thing I try to find doesn't exist. Okay, so my parabola never cross the x-axis. Okay. I have enough information to start. I open Desmos. Okay, super. I open Desmos. I switch in my screen, share my screen with the Desmos. Okay, here I have Desmos, no? Yes or no? Okay, I condense in this information. I put all enable. I create one question. It's the question 3, no? Question 3. Okay, in the question 3, the function is called, the name is g of x. And g of x is equal x squared. Let me use on the keyboard for this, x squared minus 5 x plus a. Boom. Look, patapum, patapam. And look at the vertex. The vertex is 2.5, 1.75. Okay, Desmos is smart guy and always indicate some point can consider it useful. But okay, I don't care. I put my own. I put here 2.5, 1.75. Boom. I put a label to indicate it's my important. What more information is important? Well, it's important the y in a set we discovered it was parenthesis 0.8. Look at that. Wow, amazing. And also it's important the axis of symmetry, que es the line x equal the h value, que the h value is 2.5. Entonces 2.5. And this line, you know, is hypothetical, mathematical, auxiliary. Therefore, I put in dotted line. I change the style to dotted line. Oh, so we have only 2 points, but we can use in our imagination. And here we have another additional point, get symmetry, because the axis of symmetry, no? So we have another point again. It should be, in my opinion, 5.8. Let me put it here, comma, 5.8. Perfect. A plus I have in this test. Any question? Okay. No? Everything okay, guys? Something wrong? Something weird? Confusing? I do it too fast or no? I do well. Too fast? No answer. What mean no answer? You follow me or no? Launa, it's okay? Noel, good. Andreina dice good. One more opinion. This is for you, not for me. I know that part. Okay, this is review. We try to refresh your memory in that part. Okay. Let's move it on. Okay, it's good. It's good. Who say it's good? I don't know. Okay. Whiteboard. Do you see whiteboard? Question 4. Okay. Question 4. Santiago, definitely. Do you see the whiteboard or no? Y is equal minus x plus 3 squared plus 5. Entonces, immediately you identification. Okay, you are doing one problem of the quadratic function again. But in this case, the quadratic function is expressed in vertex form. It's like that. Okay? Entonces, identification que A es -1. Look at that. H is -3, opposite sign. See, in the formula, in the general formula, you see minus. In the particular example, you see plus. That's because we have double minus. Entonces, the value of the H is -3 and K is 5. Oh, nice. Super fantastic. I know that the vertex of this parabola is located at the point -3, +5. And this parabola open down. Open down. Because A is negative. Okay, and this point is the vertex, this point. Okay, so one more information we need. Well, we need the y-intercept. Y-intercept. We need x-intercept. Let me try. Y-intercept is when x is 0. We have no function notation, but you want function notation because you are familiar. You put h of x. You put any arbitrary name. Well, actually, you put 0 in the x. You replace is minus 0 plus 3 squared plus 5. And 0 plus 3 is 3. And 3 squared is 9. But we have minus in the front is -9. Plus 5 and -4. Okay, therefore the point is the -4, 0, -4. The point, the famous point is 0, -4. Remember, the supposition was that x is 0. This is x. And this is y after the evaluation. And in order to find the x-intercept, well, we solve the quadratic equation. So I am forcing the quadratic equation like that. Minus x plus 3 squared plus 5 is equal to 0. I try. Is manipulation here. Minus x plus 3 squared equal -5. Divided by -1 both sides. Become positive. X plus 3 squared equal 5. Square root both sides. X plus 3 without square root and square is plus or minus radical 5. Radical 5 prime numbers. It's impossible simplification more. So x is equal -3 plus or minus radical 5. The thing is that I want to do the graphic. So to do the graphic, I don't leave it like that because this is the exact answer. I need the decimal approximation. I break it down like that, -3 plus radical 5 and -3 minus radical 5. Because I compute approximately using my calculator. My calculator is -3 plus radical 5. Radical 5. Is -0.76 using 2 decimal places to approximation. And now minus both. Subtraction now is negative 5.24. Negative 5.20. Therefore, we have 2 points. The points are minus 0.76, 0, and minus 5.24, 0. Okay, so we have parabola. Look, this is my picture so far. My picture is one parabola up and down. We have axis of symmetry here. Down, 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 down. And the axis of symmetry is the vertical line can happen at x equal minus 3. That's always the h value. And this parabola crossed the x-axis in this point. Chum, chum. And crossed the y-axis in this point. Okay, so I want to integrate everything together. Okay? Entonces, no more what's the time on the piece of paper, because the most important information I have, now I switch into Desmos. Desmos is my fantastic graphic calculator, totally free and color, beautiful. I love you, right? I open that. Okay, this is example 3. Oh, I forgot to put inside this. Okay, now I create one. This is question 4, no? Question 4. Question 4. But I want that the question is organized one by one. Question 2, question 3, question 4. So I can click here and drag. Question 4. Okay, press enter. You type in the, sorry, no, I put on enable question 3. I focus on the question 4. And question 4 is y equal minus parenthesis x plus 3 x plus 3 square, no, close the parenthesis, square, plus 5. Boom. Look at the vertex, guy. Look at the vertex. Let me close the keyboard for the Desmos. I click on the curve. I see the important point that they consider good. Look, it's the vertex, negative 3, negative 5. Wow. I type it here. Negative 3, negative 5. Negative 5, no, positive 5. Positive 5. Boom. One more important point. Well, this point, que es the y-intercept, que es 0, negative 4, comma, 0, negative 4. And this important point also, I click on the curve, que es the weird guy, que es 0.76, negative 0.764. Decimal approximate 3 decimal place. Better downs, so that me. Entonces, comma, negative 0.764, 0. This is the x-intercept. And the other x-intercept I don't remember is negative 5.236. Comma, separated by comma, each one guy, negative 5.236, 0, no? Boom. I forgot the most important part. I forgot the axis of symmetry. It's the vertical line x equal, no, mistake. Carajo. Erase that part. Undo. Okay, it's okay. Now I click, let me see. I click here, next line. The line, vertical line, x equal negative 2.5. 2.5, no. It's negative 3. Negative 3. Es black color. dotted line. This is my axis of symmetry. I suppose, using my common sense and my imagination, okay, we have another important point here, que is symmetric with respect to this. Okay, this is 4. Let me see now, this is 0,4. And this is x equal -3. Basically, the distance from the axis of symmetry on the origin is 3. And this is 3 in another direction. So I suppose, using my common sense, okay, we have 1, 2, 3. This point is the point -6, -4. Let me see if I am right or I'm wrong. I don't know. It's -6, -4. Boom. I got it. I changed to blue color because any point I use in the blue color, yeah, put a label exactly the same. This is my beautiful parabola. Any question? I have a total 1, 2, 3, 4, 5 points. Axis of symmetry, open down. Any question? Let me save the information that we have so far. Yeah, it's sent to you by email, the link connected with this decimal. And we can change, guys. This is when you receive the link and you open decimals in your account. If you want to change the value, something, it doesn't affect my work. My work is in my account, not in your account. When I share with you the problem. Any question? Anyone follow me everything very well or no? Or you are totally lost? Partial lost, totally lost. I need to call 911 or no? No, 911. Emergency. No? Everything okay? You follow me? Okay. Number 5. Number 5. Come on. Good. It's Andreina is good. Because you are an excellent student, Andreina. Suppose this function, f of x, equal x squared plus 4x plus 3 divided by 9 minus x squared. This is classical rational function. Because it's division, no? Two polynomials. So what is the first thing you should do? Factorization. Factorization of the polynomial at the top, factorization of the polynomial at the bottom. Let me try. Okay, in the top is trinomial. You open two parentheses. I suppose that the combination of words is 3 and 1. Because 3 times 1 is 3, and somehow 3 plus 1 is 4. Plus. End the story. And this is the difference of a square. You open two parentheses. Is 3, because the square root 9 is 3, xx, plus or minus. Something like that. Okay? Entonces you can see, wow, look at that. This is an important moment. Okay, this factor is cancelled. Yes or no? It's the same. I don't care if it's x plus 3 or 3 plus x. And the addition is perfect commutative. You can interchange. It's the same. In subtraction, no, but in addition, yes. So basically, we discovered that we have one whole in my graphic. Is at x equals -3. There's 0 here. -3 plus 3 is 0. 0 divided by 0, undefined. And my new expression is x plus 1 divided by 3 minus x. This is equivalent to the original. It's easier to the original, but it's not 100% equivalent. It's equivalent except in a whole, que es -3. Because this have no whole, and the original, yes, have one whole. But I need to do the graph and the test of the original, not the equivalent. But it's okay. The graph is identical, except that in this graph at -3, we have no hole. It's like that. In this, we have a hole. It's like that. A hole. It's the only difference. Okay? Super. Now let's move on to the next step, que is find the y and x and z. Table de función es 0. So you evaluate the function and 0, and the top 3 stay 0, 0, 3, and the bottom 9. Simplification 1/3. The YNZ, I have the point 0, 1/3, and decimal is 0.3 repeated. Okay, I have some idea how I locate the point, 0.3 approximately. Okay, and the action set is when the f of x is 0. Now remember, the only thing you should do is take the top part equal to 0. And the top part equal to 0, you can write like that. Oh, I prefer write like that, like a factorization. But actually, I prefer the easy way, because the easy way is equivalent to this x set and -3, but -3 is a whole, and you are finding the x in a set. So I don't care the whole. So basically, it's x plus 1 over. So I forget about this. You take this equal to 0. But in conclusion, is x plus 1 equal to 0. It's a -1. X equal -1. We have the x in a set, que is the -1, 0. Okay, so now, in this moment, okay, we have one whole and -3. Okay, we have one y in a set case in this point, and one x in a set case in this point. Okay, okay, we are doing well. Now, very Gaussian, we have, yes, you take the polynomial at the bottom after the simplification, que es 3 minus x, and you enforce it to be 0. It's obvious que x is 3. So we have a very Gaussian. So in this moment, I don't know why I want to start doing the roughly sketch. We have, this is y-axis, this is x-axis. We have one y in a set and 0.1/3. So I suppose this guy is 1, this is 2, this is 1/3, look like that. This is 1 point, get this. And -1 is -1 here. It's an x in a set. We have 2 points, chung chung. And also we have entry 1, 2, 3, 1 vertical. Well, see, I connected this point and this point. I don't know exactly after the additional point, no? Horizontal. Horizontal always is the same analysis of the degree. What is the degree? It doesn't matter if you are doing the analysis in the original or in the new one after the simplification. In both cases, we get exactly the same solution because it's 1 here and -1. That is y equal -1. You are doing this is 1 coefficient here and -1 coefficient. It's the same. So in -1, we have the horizontal. Horizontal. Okay. One more information we need. Well, we need symmetry. It's obvious that we have no symmetry. In this example, why? How do you know that? Because when you replace x for -x, only the square guy stays the same. Suppose that I'm doing in the region, but this change, and this stays the same, and this is stay the same, and this is stay the same. But see, we at least one change, no symmetry, neither. That means the positive part and the negative parts are completely different. And the additional point. Well, let me try to understand where is located our additional point that we need. Well, we have 1 point here. Okay, is the x in a set. We have 1 vertical. To be fantastic, can you evaluate in 4 or in 5 or in 6? So you pick one value in this interval. Would be fantastic also that you evaluate in 2 or you evaluate in 1. I don't know. I like 1. I like 1. I like 4. I don't know why. There are no reason because I like. Here is -1. So I pick -2 maybe. The value for, remember, you evaluate the function in 4, you evaluate the function in 1, and you evaluate the function in -2, and you plot that. But not here, sino en decimos. Okay? Let me go. Good, I am here. This is question 5, no? Yes, question 5. Okay. Plus, folder, question 5. Now, click and drag. Oh, no, too much. Here. The rest, if you want, delete. Enter. Is f of x. This is the region, f of x. F of x equal. Because I'm using f of x en another example. Entonces, the decimal understand que es the same f of x. You cannot see. I'm sorry. Okay, Andreina. Let me try again. Now, Andreina? You see or no? No? Okay. Okay, share screen. Stop sharing and share it with the decimal. Now, Andreina is okay? Super. Andreina, look, Andreina, I make a mistake. I put f of x and immediately, without put anything, they graph it is. The reason is because in the question 2 and the question 3, I call f of x. So let me change the name. I put p of x. P. Or M, or N, whatever the letter you prefer. P. I don't know why I like P. Okay. P of x is the function que is complicated because it's top and bottom is x squared. Open parentheses. I like to open the parentheses to enclose everything in the top. X squared plus 4 x plus 3 divided by something divided by 9 minus x squared. Boom, perfect. Look at that, the famous point we found was, this is the y, and it says 0.1/3. Okay, this point is 0.1/3 or 0.32 repeated, much better in fraction, because see, I put in decimal, maybe I need to truncate the decimal to say maybe I lost information. Another important point, click here, is -1, -1, comma, separated by comma, -1, -1,0. This was our 0, x-intercept. And also we discovered the line, the vertical line, que es x equal 3, no? X equal 3 positive. Boom. Pero no green color, no, black color. Dotted line. Super. This is my vertical asset. Nice. And my horizontal, que es y equal -1. Y equal -1. Again, black color, dotted line. Okay, we almost finished. So I propose you remember, I try additional point que in the blackboard and whiteboard was in 2, and 4. Let me check it out. In 4 and 1 and -2. Okay, we come back to decimals. Okay. Wait a second. Switching. Okay, super. Switching to. Okay, okay. And 4, here, why not? Separated by comma, 4, 4, the function, que the name of the function is P, evaluate in 4. Okay. Look at the F5. Look, 4, 4, negative 5. Another point I proposed you was 2, no? Separated by comma, 2, P, evaluate in 2. Look, it's 2, 3. Wow, nice value. And finally, what is the last one? Last one I don't remember, was negative 2, no? Negative 2, yeah. Comma, negative 2, P, evaluate inside. You put it inside the argument, in the parenthesis, negative 2. Negative 2. Maybe negative 2 is not good. I evaluate negative 4, but it's the same. Okay, how many points I have in total? 1, 2, 3, 4, 5. We have the horizontal, the vertical asymptote. Suppose que is enough to understand the curve. Any question, guys? Okay. Okay. How do you feel? And do the graph of the rational function. Strong, weak, it's complicated, too many steps. Sorry, this is the called algebra. This is not gonna get the algebra, okay? Okay, let's move on to the whiteboard. Okay. Okay, super, whiteboard. Erase everything. Okay, let's focus in the question 6. The question 6 is a little bit weird. I want to explain in detail now. Suppose x plus 5, x minus 4 squared, greater than 0. This is the inequality. This is the polynomial inequality. By the way, somebody know me do the factorization of this. Therefore, I don't do the factorization. Okay, this time this work is doing. Nice. What is the problem? The problem is, remember I explained, when the exponent is even, you delete this or partial delete. Let me explain in detail the idea. Let me try to explain, because it's very, very complicated. This guy, que is x minus 4 squared, is always positive, regardless the value of the x. See, I try to do the graph only of this part. Look, this is a parabola, and the vertex of this parabola is in 4. 1, 2, 3, and 4. This is 4. This is a parabola that opens up, and the vertex is located at the point 4, 0. But this parabola is always positive. Do you see? This is a y-axis, except in 4. It's 0. So what is the conclusion? What is totally delete? Totally delete o partial delete. Entonces, bueno, professor, we cannot do this problem in the traditional way. You can, of course, but no, you need to be aware that this is a special case, special inequality, que you solven super fast, que you solven relatively easy. Entonces, you realize one factor is even exponent. Therefore, I can delete this factor. Pero partial delete or totally delete. This depends on this sign. This depending of this sign. See, this sign is greater than or equal to 0, greater than or equal to 0, is totally delete. Why? Because this parabola, look, suppose que es only greater than or equal to 0. So this is always true. This is always true because this parabola is in the positive part and includes 0. So regardless the value you plug in here, always is non-negative. So that's positive or 0. So this is completely true. And you delete totally. And this inequality is only x plus 5 greater than or equal to 0. Wow, entonces this is linear inequality. Exactly the same we are doing in the test number 1. Piece of cake. Okay? But what is the problem? When it's partial delete. When it's partial delete, in this example, I put intentional, of course. It's partial delete. Let me copy one more time the original problem. Okay? A modification to say you don't understand very well. No equal here, square. So you immediately say, wow, square is delete, pero partial delete. Why partial delete? Because specifically for, so at x equal 4, let me plug in here, let's see what happens. 4 plus 5 is 9. And 4 minus 4 square, this is 9, this is 0, 4 minus 4 is 0, square is 0, and 9 times 0 is 0, and 0 is no greater than 0. You get totally false statement here. Entonces, in this moment, when this no equal, this is the key idea. When it's equal, totally delete. When there's no equal, like this example is partial delete. And how you partial delete? How? Well, it's relatively easy. You, for example, you copy the other binomial, okay, no include 4, because I know in 4 what something weird happened. You copy x plus 5 greater than 0, and you put like a compound inequality and x no 4. Because I know in 4 we have situation. We have some problem. Okay, nice. Now I solve this compound inequality, separate separately. The x is greater than -5 and no 4. Entonces, as always happen in the compound inequality, the last step is graphically. This is my famous or real line number, positive, negative, infinity, positive, infinity, 0 in the middle. Entonces -5 here, 1, 2, 3, 4, 5, -5, and less than, greater than, sorry, -5 is to the right. It's to the right, not to the left. It's to the right. I highlight to the right, but what happened in 4? 1, 2, 3, 4. And 4, we have a hole. So now the solution is, look, let me show you in blue color, parentheses, no include -5, no. You highlight that part. But in 4, we have a hole. And this continues forever. But the answer I want in the test. In interval notation, always, solution for the inequality, I need the answer in interval notation. Es paréntesis -5, comma, 4 paréntesis, que es this piece. And the second piece is union 4, infinity. End of story. I finish. Okay. Let me summarize in the rest of the time we have. Suppose. Look at that. Suppose we are inequality. Let me complicate your life. X plus 3, x minus 5 square, x minus 2 square, x minus 4 no square greater than 0 or less than 0. I don't care. You suppose it's equal. This and this delete, totally delete. Okay? Entonces you dedicate for solving this part and this part. Similar to the thing we are doing before. Compound inequality, critical value, partition, etc. Suppose now, x plus 3 again, x minus 5 square, x minus 2 square, x minus 4 no square, greater than 0. Entonces, you convert this inequality in one compound inequality. How? X plus 3 greater than 0. Comma, que comma means and. X no 5. Because it's exponent 2, no? Comma, X no 2. 2 holes. We have 2 holes. Comma, X minus 4 greater than 0. So we indicate for solving this inequality and this inequality together, like a compound, yeah, I know in the moment in the 5 and 2, we have 2 holes. You get the idea or not clear? Confusing or clear? Confusing or clear? Clear! Okay. Guys, we have no more time to continue. Okay?
Before the link, let me take a picture, please.
Please, 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 please. It's yours. But let me make it zoom. Is it okay for you or enlarge a little bit? More clear now?
It's fine. Thank you, sir.
It's fine. Okay, super. Take a picture, mister. And remember, I will post it in Blackboard, and you. I post it in Blackboard every day. So when I finish, I upload in Blackboard this video. And YouTube, I post it the weekend. I have more time to post it, no? Okay, but we have time to see that. Okay, super. We are the best in Miami-Dade College, guys. Thank you, professor. Thank you, student, for paying attention. You are good students. I am so proud of you.
Thank you, sir. Have a great night.